Hi, this is Dr. Kunka Bheemalingappa. I heartily welcome you. In this video, we are going to discuss about the important list functions, namely map, reduce, and filter. So first we discuss about each of these functions one by one in more detail with example. Coming to the function that is a map, it is used for transforming every value in a list by applying the function to it. So it takes two arguments. One is a iterable object that is to be processed and the function to be applied. So this function returns a map object by applying this function to the list. So the syntax, it looks as follows. So that is map, two arguments, that is name of the function, that is what function you are going to apply, and that is on what list you are going to apply this function, that is iterable object. So since the map function returns a map object, so we convert it to a list by using the function that is a list. So let us look by an example the usage of this map function, then we look at next example. So here at first I am going to display a list of keywords. You know how to display the list of keywords in Python, that is import keyword and then keyword.kw list. So let me, if you want to make clear the all the outputs, first let me clear and then we can run one by one, clear all outputs. Yeah. Now in the order I can execute right one by one. Let me execute this cell, so which displays the list of keywords. So there are about 35 keywords right in Python. So this is the list of keywords. In this keywords you can find one important function keyword, namely that is a lambda. So it can be used for that is define a function. So first we discuss about this lambda function, and then we discuss about other important functions, namely that is map, reduce, and filter. So coming to this lambda function, it consists of the keyword that is a lambda followed by a comma separated list of arguments and the expression that is to be evaluated using the list of arguments. So this is the syntax, that is lambda is the keyword and then list of arguments. They can be if there is if there are say two or more arguments, then you need to separate one from another using a comma, and this is the expression. So they both must be separated with this colon. So after the last argument in the argument list part, I have to use this colon, so which marks the beginning of this expression. So this is the syntax. Here I have written one function for finding the cube of a number. So you know this lambda you can find it in blue color. It means it is a keyword. In the list of keywords also I have shown you this keyword, and then after this keyword lambda you can find list of arguments. So here you have one argument, that is x, and after this you have this colon, so which marks that is the end of this argument list, and after this colon we have this expression. So expression here is what cube of this x. So once you define this that is once you execute this statement, later on we can use this function, right, cube, with whatever the value you want to pass as argument to it, right, you can pass. So first let me execute this cell. So here I have executed, I have written a function for this finding the cube of this x using a lambda, and then I have passed, I'm making use of this function that is cube with the argument as that is a 5. So it has written a value that is 125. You are known 5 power 3 is 25. So once you define this function, later on you can use it anytime you need. So this time if I wanted to know the cube of 9, you can just pass the argument that is 9. So later on you can just make use of that function. So that is cube of 9, we are known that is 729. Suppose for example if I want say for example some other number, so a cube of like say 4. Once you have defined, okay, later on, whatever the number you want to, for whatever number you want to find the cube, you can just pass that value as an argument to this function. So cube of 4 is 64, you are known. So you have got that. In a similar fashion, we have written a function using this lambda to know that is square of say some number. So square means what? It is multiplied, okay, itself, that is, okay, twice. Square of x in the sense like say x into x. So we have written this lambda function for finding the square of x, and later on in place of x you can pass right any argument that whatever you wish to find the square of that number. Yeah. So let me execute this. So as usual, lambda is a keyword, this x is a argument, and this colon is a separator which separates this argument list and from the expression part. This x star 2 is an, okay, expression here. So they both must, and this x is a argument, they both must be separated with the colon. You can have 2 or more arguments. So based on the expression, you may need 1 or more arguments, right? So for this case, I need only 1 argument. So you can, if you want to rewrite this as say x into x, right, you can write. Otherwise, x star 2 also you can write. So let me, okay, execute this so that you can understand. Say square of 5, I got it as, okay, 25. And once it is defined, and once you have executed that cell, okay, later on in any cell you can use that, okay, function name. So square of 10 is 100, we are known. So you have got that square of 10 as, okay, 100. I told you that you can write this function as a what? Yeah, if you want to rewrite this square, yeah, x into x, right, you can write. Yeah, so let me create a new cell. Here, yeah, let me copy that. And I'm just changing the formula. So x star 2, instead of that, I'm going to use x into x. So this is an expression, right? X into x. So if you want to change this name, like say, if you want to avoid the confusion with the previous name of this function, let me give it as a just, okay, square, SQR. It is up to you. So, and then we can find square of, for what number you want to find, you can find, it is up to you. Yeah. So this way also you can define this, okay, square of a function. It is up to you. So let me execute this cell. So you have got this, okay, square of 5 as, okay, 25, like this. Here itself, right, if you want to change its value, you can change, it is up to you. And all, yeah, so suppose for example here itself, if I want to find the square of, okay, 10, then you can just make that change, save, and you can just run so that you can get that is square of 100. So later on also, if you want to find, okay, some square of say 8, you can pass that, okay, 8 as an argument now. So this time we can get it as so there are I have, for the same function, I have used the different name. So using any one of the function this time, right, you can calculate the, okay, square of number. So in 2 ways I have defined this, okay, square function. It is up to you. So whatever you want to use, right, you can use, okay, no issue. And so that is what about this lambda function. And this lambda function, it involves, okay, 2 arguments. Earlier you have seen a lambda function with only 1 argument. So this lambda is a keyword, and here this x and y are arguments, they both are separated with comma. After that, after this last argument, that is why you have colon, which separates this expression part from the argument part. So here expression is what we are doing, we are trying to find the squares of the numbers, 2 numbers, and then we are finding the sum of those cubes. So that is what this, okay, function. So cube of a number in the sense that is x power 3, that is which is same as x into x into x. X is multiplied itself, that is x. In a similar, that is x cube. In the same fashion, you have that is y cube. Y is multiplied itself, that is thrice, y into y into y. So y star star 3, it means is y into, the meaning of this is y into y into y. So in any way, you can define this function. If you want to write it as y into y into y or y star star 3, you can write it, is up to you. So first let me execute and later we will see. So so you have two arguments. So while calling this name of this function also, you have to pass two arguments. So I want to find the sum of the cubes of two numbers, namely that is 2 and 3. So then 2 power 3 is 8 and 3 power 3 is 27. So 27 plus 8, that is 35 is the answer. That's what you are going to get. So let us execute and see. So you got that correct answer. And later you passed, this time instead of 2 and 3, you have the values, that is 4, 6. 2, 3 or 3, 2, order doesn't matter. Both are cubes here. So let me execute this so that you can understand. So this is a cubes of sum of the cubes of 4 and 6. That is 4 cube plus 6 cube. You are known 4 cube is 4 into 4 into 4 and 6 cube is 6 into 6 into 6. So if you evaluate this, you are going to get your answer as like this. So if you want to, yes, if you want to change this formula itself, right? You can change this. For only one, if you want to change, right, you can change. Otherwise, for both, if you want to redefine, you can define. So x into x into x. So that is x cube. So only for x cube, I have redefined this function. It is up to you. Yeah, it is lowercase x. So I have defined this cube in two ways. That is multiplied itself 3 times, otherwise rise to 3. So I just made the changes, so you can save and run. So this time also you're supposed to get the same answer. So you got the same answer. So this time for this one, for these values also you have got the same answer. Earlier I have already run and you are known the answer, so I just redefined that function. So this is what about this lambda function. Now we are going to discuss, because I'm going to make use of that lambda function in this map function. So I thought of discussing about this lambda before this map. Now we are going to discuss about this map function in more detail. So theoretically you have already seen. So it is used for transforming every value in the list. So it takes two arguments. One is the function and one is the iterable object. So this is the syntax already have seen. So map, this is the name of the function and this is the iterable object. So two objects. So let us see an example. And at the end you need to apply this list function, because this map function returns an object. So if you, so this is the list consisting of 5 values, 1, 2, 3, 4, 5 in the order. And here I have defined this map function. So already have seen this is the lambda function for finding the cube of this x. So earlier you have found only for x, but this time you want to find this cube for all the numbers in this list. So that is the reason you need to pass this list as a argument to this function. So the name of this list is what? LST. So that is this argument, and this is lambda, right? So that is function and that is a iterable object, that is list here, right? So lambda, that is x colon x star star 3. This is the first argument. This is a function, and second argument here is what? That is the list. And outside of this, I have used this map, right? So for the map, you have to use this as an argument. And at the outer side, I used this list in order to convert this object that is returned by map into a list. So this is how this it works. So this time you can have the cubes of all the numbers that are listed in this list. You know what we have there in the list. You have okay list of 5 values, so you are going to get a cubes of okay all those 5 values. So let me execute and okay show you so that you can find. So 1 cube is 1, 2 cube is 8. So like this, 3 cube is okay 27, 4 cube is 64, and 5 cube is okay 25 into 125, 25 into 5. So this is the output, right? That's what you can get. Say 1, 8, 27, 64, and 125. So this is how this map function okay it works. So here what I have done here is I just changed the values of this list. So everything is same, only values of this okay list are changed. Earlier 5 values 1 through 5 in the order, but this time I have only 3 values 9, 5, 7. So for these values you are going to get the cubes of this okay listed numbers in this list. That is 9 cube, 5 cube, and 7 cube, right? So so let me execute and show the okay output. So 9 into 9, 81, 81 into 9, that is 729 you have got. That is cube of 9 is 729, cube of 5 is 125, cube of 7 is that is okay 343. So this is how you got the cubes of all the elements right in that list using this okay map function. Instead of cube of elements in the list, if you want to find there is squares of the elements in the list, then you can just find a change in the formula. For the cube you have, that is it is raised to 3. For square it will be okay raised to 2. That is the only difference. Here I have used the argument as x, here I have used the argument as y. That is the only difference. So whatever you want to use the argument name, right, you can use, okay, it is up to you. Rest of the things are okay self-explanatory. So this is the original list, and this squares of this list, it is going to get stored in this name, that is LST SQR. So using that name I am going to print the squares of list of these numbers. You know, square of 2 is 4, square of 4 is 16, and so on. So for these numbers, okay, whatever you have listed, so you are going to get the okay squares. So that is what square of 2 is 4, square of 4 is 16, square of 5 is 25, and so on, like this. So this is how, right, if you want, you don't need to find this cube or square of an element separately, okay, one by one. For all the elements in the list, you can find this way by writing the function once. So this is what this map function. I hope you are clear. And here I have given right one more example. So map, this is the absolute okay function. This is the absolute function. And here this is okay list. You can I have taken here the list as okay directly instead of having the values in a list and having some name for that, and instead of using that name and directly I could have passed that list of elements as a argument okay for this okay function. So this is how it works. So let me execute this so that you can understand. Here we have both negative values and positive values. So absolute value of a number, in the sense it returns only a positive value. So all values are going to be what? There is okay positive values only. See 1, 2, 3. First 3 numbers are negative numbers and last 2 numbers 4, 5 are positive numbers. So on using this okay map function in the list, all the values are okay turned into positive values. So this is how, right, you can use this okay function. That's all about this okay map. Now we can discuss about one more okay important function in Python, namely that is a reduce. So as the name implies, it reduces to a okay single value. So after, suppose for example, so let me go to this. Now we discuss about this reduce function. It also takes 2 arguments, namely function and iterable object. So, but it is available in functions function tools module. If you want to make use of this function, you have to import this function tools, and then you can okay work on this. So if you want to compute the sum of the cubes of all elements in a list, so when you sum all the values, you are going to get okay single value, right? So in that case you can go for usage of this reduce, right? So That's what okay it says. We have seen first already have discussed about this map function. So using this map function, I'm going to know about the cubes of list of numbers in the list. So already have explained this okay code. So we have okay 5 values. If you want the cubes of these values, then you can execute this, so that I have passed the 5 values. You got the okay cubes of these okay 5 values. Now if you want to find the sum of okay all these elements, so after defining this, there is a map. I'm importing this function tools, and then I'm using this okay function, that is okay reduce. So this is a syntax. That is up to this colon. This is okay lambda. It is a function. It has okay 2 arguments, and what this function it is doing is this. That is it is finding the sum of the elements in the sum of the elements that okay whatever you are passing. Of course, right, you are passing this list to this okay function. So all the elements in that list, they are going to get okay added, and that result is going to get assigned to this name, that is sum cubes, and using that name, right, I'm going to okay display those values. So you are known cubes of this first 5 numbers is this, and I'm trying to find the sum of cubes of all these 5 elements. Okay, 1, 8, 27, 64, 125. So sum of this 1, 8, 27, 64 and 125 you are going to get using this reduce function. But before you use this reduce, you make sure that you have imported this function tools, being known that this reduce comes under this function tools, right? Yeah, let us execute this. So this is answer, right? Okay, that what you are going to get if you are going to sum right all these values. Okay, so 120 plus 60, 180 plus 20, 200, and then 201 plus 8, 209 plus 7, 216 plus 4, 220 plus 5, that is 225. So this is how this it works. So that is what this okay reduce. So here you have found okay sum of these cubes. If you want to find product of these cubes of these numbers, what change you can find in a formula? Instead of say that is x plus y, how to use that is x into y. So I just, in the previous case, I just summed right all these cubes. So in this case, I'm going to what you say multiply right all these cubes. That is the only difference, right, you can find in this, and rest of the explanation is same. So this is about this. So this is the value that what you are going to get on finding the product of right all the cubes of these numbers. So in the similar fashion, instead of finding the cubes of numbers, if you want to find what you say sum of the squares of the numbers, so instead of this is the only a slight change, right, you can find in the formula, that what I have already defined for what you say list of okay cubes. So this is list of squares. So here you have that is 2 instead of okay 3. So at first I'm finding a list of squares, and then using this okay reduce, I'm trying to find the sum of squares of that okay list of numbers. So at first I can display what are the list of that okay squares of numbers for the given list, and then we find that okay sum. So this is the squares of the list of numbers, that is 1 for 1, 2, 3, 4, 5, these are the squares 1, 4, 9, 16, 25 respectively, and this is the sum. So if you want to find, so this is the squares. Yeah, so that is what about reduce function. Now we are going to discuss about one more important last function in Python, namely that is okay filter. So here what you can do, so this reduce, it produces okay single value. In a filter, in a list, right, if you want to filter some values after applying this okay map, you can okay filter. So that is what, and after filtering whatever the action you want to perform right on those new list, on that okay new list, right, you can perform. So let me move on to this. Yeah, this is, so we have discussed about this reduce. Now we are going to discuss about this filter function. So it takes a function and same. In all cases it is same. It takes okay 2 arguments. One is okay function and other one is iterable object, we can say. So the difference between this map and reduce is that in map at the outside you have to use this like a list function, but in the reduce you don't need to use that list because it reduces to okay single value. And then in the okay filter, now you are going to have an example on this filter. So this is the code what I have written for finding cubes of this number, and then you are going to get list of cubes. In that list I am going to apply this like a filter. So I want to have only what? That is even numbers. So that is what I have written. So coming to this syntax difference, there you find map, here you find there is a filter. That is the only difference you can find between this map and filter. So in map you have to use this okay list, and in the filter also you can use this okay list, but in map you are going to use the word map. Here you are using a word that is the filter. That is the only difference, right, that you can find. And after applying this filter, once again if you want to use this okay reduce function, right, on that result that what you got okay after applying this okay filter function, you can do so. It is up to you. First we see, right, what is the list of okay cubes, and then here we find what are this even numbers in the cube, and we are just okay displaying that. So you are known 1 2 3 4 5 the cubes. Let me execute this so that I am displaying okay both that cubes of that list and also even numbers, right, in that cubes of that okay list. So these are squares of this first 5 numbers 1 through 5, and in this you are known even numbers are what? 8 and okay 64, and rest are odd numbers. So it has included only this okay 8 and okay 64. So that is what this filter. If you want to okay filter even and okay odd numbers in this even cubes, you can use this okay filter function. So in the same fashion, so even cubes and odd cubes. For even cubes I have tested with what? That is equals to 0. For odd cubes I have to test with what? Not equals to 0. That is the rule that what we follow for even and okay odd, right? So this is everything is same, but here I am filtering only this okay odd cubes. So this time on execution of this code you are going to get 127 125. So this is the result that what you got. And finally this is okay one more example. Here we have used cubes. Here I have used that is okay squares, right, even squares, okay, and also there is okay odd squares, and rest. And here I'm using I'm finding okay squares. So I have used a value that is raised to 2. Here I have used a value that is okay raised to 3. That is the only difference. So here you are going to get okay squares of this numbers and even squares moreover. That is in this case odd squares, and below that you can find that is even squares. So first squares of these numbers are this. Square of 1 is 1, and square of 2 is 4, and so on. Square of 5 is okay 25. So these are squares, and here we have found that is okay odd squares. So of this, you know what are these okay odd numbers? 1 9 16 25 are 1 9 25 are okay odd squares. So this is what this. Here you can find there is even squares. Even square is what? That is 4 and okay 16. If I execute, rest of the things are same. Here I have tested for odd, that is not equals to 0. Here I have tested for equals to 0, and rest of the things are self-explanatory. I have already explained. So here you are getting that is okay 4 and 16. So this is how this you can use this map, reduce and filter functions in Python on a list. Thank you for watching the video.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.